So now we're going to go into part 3 of our solving systems of equations in two variables by using the elimination or addition method. Where we're going to eliminate one of the variables by adding two of the equations together after we've done a little bit of equation manipulation. So let's look at the steps involved. First, we're going to multiply each term of one of or both equations by some non-zero integer so that the coefficients of one of the variables are opposites. Then we will add the equations of this new system so that one variable is eliminated. So that's why it's called the addition elimination method. Solve addition or elimination method. Then you're going to solve the resulting equation for the remaining variable. Substitute the value found in step 3 into either of the original equations to find the value of the other variable. Then, as always, we can check our answer. So we check our solution in both of the original equations to make sure we didn't do an error. So let's look at an example. So we look at our problem. We have 3x plus y equals 7, 5x minus 2y equal 8. We're trying to get coefficients on either the x term or the y term so that they're the same but with a different sign. So when I do these, I look for are either one of the variables plus in one of the equations and negative in the other. And I see that the coefficient of the y is plus in equation 1 and negative in equation 2. So that kind of tells me that if I multiply equation 1 by 2, I would be able to eliminate the y's when I add the two equations together. So I go, here's equation 1. I'm going to multiply it by 2. So 2 times equation 1. So literally I'm going to take all of this equation and multiply it by 2. So 2 times 3x is 6x. 2 times y is 2y. And equal 2 times 7, which is 14. And I'm going to keep equation 2 in its original form as 5x minus 2y equal 8. And now if I add these two equations together, look what happens. 6x plus 5x gives me 11x. 2x minus 2x, they get eliminated. And that equals 22. Now I can solve this resulting equation for x. So I'm going to divide both sides by 11. And I'd have x equal 2. So here's my first step, is to multiply each one. So this is step 1. Then I took that, after I did that, I added the equations to eliminate one of the variables. This would be step 2. And then step 3, solve the resultant equation. So this right here, so here's step 2. And then, and step 3 goes here. And now step 4, I'm going to substitute back in to one of the original equations my variable value for x. I'm going to substitute in here because y, I can just solve for y here. So I'm going to say 3. So I'm going to take equation 1 and put x equal 2 into it. So I'd have 3 times 2 plus y equals 7. 6 plus y equals 7, and I just subtract 6 from both sides, and I find that y equal 1. So I get the solution 2, 1. But now I want to check to make sure that that's correct. So in the original equation, I put 3 times x, which is 2, plus this y. Does that in fact equal 7? Yes. 6 plus 1 does in fact equal 7. Equals 7. Then I have to, and so I did it with equation 1. Now I've got to check with equation 2. So I look at equation 2, 5 times that x that I found minus 2 times the y, does that in fact equal 8? 10 minus 2, sure enough, 10 minus 2 does equal 8. Let's look at another example. Now in this problem, using the addition or elimination, whichever one you'd want to call it, method, I look at equation 1 and equation 2. And I'm going, wow, both of them are positive. So now I want to choose the ones that, for me, I always like to choose the ones with the smallest numbers. So I say, I'm going to make it so that both of these coefficients are the same number with opposite signs. So I'm going to multiply equation 1 by negative 2 and equation 2 by a positive 3. If I do that, I'd have negative 6 and a positive 6. So this would be step 1, figuring that out and executing it. So negative 2 times that whole equation 1 and 3 by my equation 2. So when I do that, I'd get, pulling it through, I'd get negative 6x minus 8y is equal to negative 34. This is my new equation 1. Now here's my new equation 2, where I'm going to take this 3 and multiply 2. So I get positive 6x plus 21y, and then 3 times 19, you get 57. Now it's time to add the two equations together. So this is step 2. So when I add them, negative 6x plus 6x, they eliminate. And then I have negative 8 plus 21y, I would get a positive 13y. And then 57 minus 34, I'd get 23. Now I'm going to divide both sides by 13. And I get 23 over 13. Now it's not the nicest number, but I'm going to work through this and I'm going to find y. I'm going to find x. So in step 3, I'm going to choose one of the equations to use, and I'm going to use equation 1. So in equation 1, I'm going to put y equal 23 over 13 into it. So I'd have 3x plus 4 times 23 over 13 equal 17. So I'm going to subtract 92 over 13 from both sides. So I get 3x equal, and I have to do 13 times 17 because I got to get a common denominator. So I get 221 over 13 minus 92 over 13. So I'm going to subtract 92 from here. I get 3x equal 129 over 13. And I'm going to solve for x, so I could divide by 3, or it's the same thing as multiplying by a third. And I'd have x equal, the reason why I did that, because I saw that that's 9 plus 2 plus 1, that's 12, so I know 3 goes into there. 3 goes into there, 43 times over 13. So x equal 43 over 13. And there's the solution, 43 over 13, 23 over 13. So even if we don't get nice numbers, we still can do this, and we still can do our check. We still can say 3 times 43 over 13 plus 4 times 23 over 13. Does that in fact equal 17? Does that equal 17? We keep on going. Does that equal 17? Well, let's look at what 13 into 221 is. And if I do 13 times 7, that's 91. So that equals 17. So in fact, 17 equaling 17, 43 over 13 and 23 over 13 does work. I'll have you do equation 2 to see that in fact it is true that this coordinate solves problem equation 2 also. Let's do one more. So let's look at this problem. So here's my equation 1, here's my equation 2. I look and I'm saying, which one do I want to get rid of? I see that the y, one is negative, one is positive. So I'm going to multiply the equation 1 by a positive 3 and equation 2 by 5. When I do that, I'm going to take 3 times 3x minus 5y equaling 11, multiply each of those by 3, and then on the second equation, multiply everything by 5. Oops, don't need that. So I'll get my new equation 1 and my new equation 2. So my new equation 1 will be 9x minus 15y equal 33. Then I'd have 5 times 4, that's 20x for my new equation 2, plus 15y equal 25. And we see that, so that was my step 1, was to multiply. So here's step 1. Now I'm going to add the equations so that one of the variables, in fact the y variable, gets eliminated. So it does. So I get 29x equal, and then because those guys cancel, I'd be left with 58. Now solve for your variable that is left. That's step 3. So I'm going to divide both sides by 29, and I would get 2. That's step 3. Step 4 is coming back here and plugging it into one of the original equations to solve for the other variable. So in step 4, I'll put it over here, I take either one of these equations. I'm just going to take equation 1 and solve with this new variable x that I put in here. So 3 times this x, 2, minus 5y equal 11. So 6 minus 5y equal 11. I'm going to subtract 6 from both sides, and I'd get negative 5y equal 5. So y, if I divide both sides by negative 5, would equal negative 1. So here I have 2 minus 1 is the solution to this. And step 5 would say, do the check. So I'd say 3 times 2 minus 5 times a negative 1. Does that in fact equal 11? Well, 6 plus 5, because negative 5 times a negative 1 is positive. And sure enough, 11 equals 11. And I'll save for you to show that this does in fact make this true. So you make sure that you do the check on equation 2. Well, thanks so much for watching.